Welcome to the Network Plus Prepcast, your dedicated audio companion for mastering every objective on the CompTIA Network Plus certification exam. This series is produced by baremetalcyber.com. File and print services form the foundation of local and enterprise network environments by enabling users to share files, access shared resources, and interact with centralized printers. These services are deeply integrated into productivity workflows and are essential for collaborative work environments. Understanding the underlying protocols that support these services is critical for anyone pursuing a career in network administration or preparing for the Network Plus certification exam. On the exam and in real-world networks, knowledge of how file and print services operate, especially the protocols that enable them, is directly tied to configuring access controls, securing data in motion, and maintaining efficient resource availability. This episode, titled File and Print Services, SMB and SQL protocols, focuses on two of the most exam-relevant protocols used in internal networks: server message block and the structured query language communication layer used by Microsoft database servers. Server message block, often abbreviated as SMB, is a protocol used for sharing files, printers, and other resources across networked computers. It is most closely associated with Windows environments, although it is also supported on other operating systems through compatible services. SMB operates over Transmission Control Protocol port 445 and enables systems to communicate directly using IP-based connection. This protocol allows a user to access a shared folder on another device, read or write files stored remotely, and send print jobs to a printer that is managed by a different machine. Because it uses Transmission Control Protocol, SMB benefits from reliable delivery and ordered transmission, which makes it suitable for file operations that require consistency and stability. Session establishment in SMB depends on the version being used. Older versions relied on NetBIOS, which involved ports 137, 138, and 139, and required name resolution mechanisms that were less scalable and efficient. Modern versions, starting with SMB version 2 and beyond, communicate directly over port 445 without involving NetBIOS. When a client initiates a session with a server using SMB, authentication is typically required. This authenticated session ensures that access permissions can be enforced properly. The server uses these credentials to determine whether the client can open a folder, modify a file, or send a document to a printer. This session-based interaction forms the basis for how file and print services are used securely across a network. SMB includes several features that make it more than just a basic file-sharing tool. It supports access to shared folders, with granular permission control that allows or restricts access to specific files or directories. Additionally, it enables file locking, which prevents two users from making conflicting changes to the same document at the same time. This locking mechanism preserves data integrity, especially in environments where multiple users work on shared files. SMB also supports browsing features that allow users to discover available shares on a network without needing to know their exact paths. This makes it easier for users to find and use shared resources, improving accessibility and usability. In addition to file sharing, SMB supports printer sharing in local and enterprise networks. When a printer is shared over SMB, clients can send print jobs to that printer from anywhere on the network as long as they have the appropriate permissions. The print jobs are managed centrally by the print server, which queues them and forwards them to the printer in an orderly fashion. This centralization helps prevent conflicts and allows better control of print output. SMB printer sharing also supports automatic driver installation, so users do not need to manually install the printer software themselves. This streamlines the process of accessing and using shared printers across departments or work groups. To improve the security of file and print services, SMB includes support for message signing. When SMB signing is enabled, all messages exchanged between the client and the server are cryptographically signed to verify their integrity. This helps protect against man-in-the-middle attacks and spoofing, which could otherwise compromise the trustworthiness of file access or printer interactions. Message signing requires both the client and server to support the feature, and in domain environments, it is typically configured through group policy. While it adds overhead to the connection, it significantly enhances security by ensuring that messages are not altered in transit. SMB is widely used in local area networks for mapped network drives and shared folder access. When a user maps a network drive, they are essentially linking a local drive letter to a remote share hosted on another machine. This mapped drive can then be accessed, just like a local folder, even though the files reside on a remote system. SMB also manages print queues, allowing multiple users to send jobs to the same shared printer without collisions. Because SMB is deeply integrated with Windows authentication, users can access shared resources using the same credentials they use to log in to their machine. This integration streamlines resource access and enforces consistent access policies. While SMB handles unstructured data like files and print jobs, structured data within enterprise applications is managed by database services. Microsoft Structured Query Language Server is one of the most common database systems used internally in enterprise environments. It communicates over Transmission Control Protocol, port 1433, and allows applications to access centralized data sets using structured queries. These databases store information such as employee records, financial transactions, inventory logs, and customer data. The SQL protocol supports real-time data access and updates, enabling dynamic applications to operate efficiently across large data sets. In a typical client-to-database communication process, a front-end application sends a query over the network to the database server. This query may request information, update records, or perform calculations. The SQL server evaluates the query, executes the requested action, and returns the results to the client. The communication is stateful and often requires authentication to validate the identity of the application or user. SQL servers use access control rules to determine what each user or application is allowed to do. Permissions can be configured to allow read-only access, full administrative control, or anything in between, depending on the role of the connecting client. One of the biggest concerns with both SMB and SQL protocols is exposure to untrusted networks. If file sharing or database access is available from outside a secured network segment, it becomes a target for brute force attacks, credential guessing, and other forms of intrusion. Attackers can attempt to connect to exposed services, exploit known vulnerabilities, or intercept unencrypted communications. For this reason, both SMB and SQL server should only be made accessible within trusted, authenticated environments. Firewall rules and network segmentation are essential for reducing the attack surface and protecting critical data and resources. For more cyber content and books, please check out cyberauthor.me. Also, there are other podcasts on cybersecurity and more at baremetalcyber.com. Server message block and file transfer protocol are sometimes mistaken for one another due to their roles in file access, but their operational models differ significantly. SMB is session-based and stateful, meaning it maintains an open connection between the client and the server while the user interacts with shared resources. This allows the user to open, edit, save, and monitor changes to files as if they were stored locally. File transfer protocol, in contrast, is stateless and relies on separate control and data channels. It is optimized for moving files between systems rather than working with them in real time. While both can move files, SMB is designed for integrated access, making it better suited for environments where files are frequently opened, updated, and shared. SMB is widely supported outside Windows environments, which is important in networks that include a mix of operating systems. Linux and macOS systems can participate in SMB networks using software that implements the protocol. One common solution is Samba, which allows Unix-like systems to share files and printers with Windows clients using the SMB standard. Through Samba, a Linux server can act as a file server in a Windows domain, or a macOS device can mount a shared folder hosted by a Windows server. This interoperability ensures that users across platforms can access shared resources without complex configurations or incompatible file formats. Troubleshooting SMB connectivity involves several key steps. The first is verifying user permissions. If a user cannot access a shared folder, it is important to confirm whether their account has read or write permissions for that resource. Access control lists and share permissions both play a role. Next, administrators should verify that port 445 is open on both the client and the server, and that no firewall rules are blocking SMB traffic. If name resolution is used, tools like ping or NSLOOKUP can help confirm that the server is reachable. Additionally, the status of the SMB service should be verified to ensure it is running and accepting connections. Event logs may also provide clues about failed authentication or denied access. Enterprise printing systems often rely on centralized print services. These services allow administrators to define which users or groups can access specific printers, apply print quotas to reduce paper waste, and control printing behavior with policies. Centralized printing simplifies printer driver deployment and reduces the administrative burden of managing individual printers on each workstation. Print activity can also be logged, which supports security auditing and helps identify excessive or unauthorized use. In some regulated environments, print logs are reviewed during compliance audits to verify data handling policies and confirm that confidential documents were not printed inappropriately. Microsoft's structured query language server security involves protecting both the database engine and the network connections used to access it. Strong passwords are required to protect user accounts, and transport-level encryption helps secure queries and responses from eavesdropping. Access to the database server should be restricted using network controls, such as firewalls or security groups that only allow approved systems to connect. Authentication methods may include domain-integrated accounts or separate database user credentials, and permissions should be limited based on user roles. Logging should also be enabled to capture failed logging attempts, unusual query behavior, or changes to sensitive records. Port number recognition is vital for configuring and protecting file and print services. SMB uses Transmission Control Protocol port 445. Older implementations used NetBIOS ports 137 for name service, 138 for datagram service, and 139 for session service. Over both Transmission Control Protocol and User Datagram Protocol, Microsoft SQL Server typically listens on port 1433, although custom instances may use alternate ports. On the exam, questions may ask you to identify which port is associated with a given service, or which port must be open to support a specific connection. This knowledge is also essential when configuring firewall rules and diagnosing connectivity problems in real networks. In Windows domain environments, file print and database services are managed centrally using Active Directory and group policy. Access to shared folders and printers can be assigned based on user groups or organizational units, and policies can be used to map drives, deploy printers, or enforce restrictions. This integration allows for seamless access. Users log in once and gain access to all authorized resources without needing to re-authenticate for each service. This centralized control improves consistency and simplifies administration. It also allows for automated policy enforcement and easier scaling of resource management as the network grows. The Network Plus exam includes questions that require you to match services to protocols, identify default port numbers, and recommend secure configurations. You might be presented with a scenario in which a user cannot access a shared folder and asked whether the issue is due to permissions, port filtering, or service failure. Other questions may require you to distinguish between stateful and stateless file transfer methods, or to determine which database service is best protected against unauthorized queries. Understanding both the conceptual and technical aspects of SMB and SQL communication will give you the confidence to answer these questions correctly. In summary, Server Message Block enables users to share files and printers efficiently within a network, maintaining real-time access and enforcing permissions through authenticated sessions. Structured Query Language Server protocols support database-driven applications by allowing structured data to be queried, stored, and managed over the network. Both services rely on proper configuration, secure access, and familiarity with port numbers to function safely. Whether you are troubleshooting access failures, planning secure deployments, or studying for the exam, a thorough understanding of these protocols is essential for success. Thank you for listening to this episode of the Network Plus Prepcast, your trusted audio guide to the CompTIA Network Plus certification. This episode was produced by baremetalcyber.com. For more cybersecurity podcasts, books, and resources, visit baremetalcyber.com. Thanks for joining us for this episode of the Bare Metal Cybersecurity Plus podcast. For more episodes, tools, and study support, visit us at baremetalcyber.com. And before you take the test, make sure to check out the practice questions in the book Achieve CompTIA Security Plus SY0-701 Exam Success by Dr. Jason Edwards. They cover every domain and are a powerful way to lock in your knowledge.